Gradeup. So today we have a second session for strength of material. All of you please join together. All of you please join together for a fantastic session on. Hello everyone. Yes, Kunal, good afternoon. Am I audible to you? Am I audible to all of you? Hello, good evening, Atulya. Am I audible to all of you? Hello, Swamiji. Okay, so let us start. Actually, I have seen that whatever I was speaking, that is coming as a subtitle. Is it? Am I right? Whatever whatever the communication I'm doing it is coming as a subtitle. Okay, is it today or it is coming from few days back? Okay, let us start our session without wasting the time, and please all of you share it with the with your friends. Share it and like it, and let us start, isn't it? So strength of material for the BARC booster and 9 plus years of experience, masters from ISC Bangalore. This is my small introduction. All of you can join me on a Telegram channel, and above the chat box my Telegram channel link will be given. Please join me there. The batches for the Vision Gate 2022 and 23 as well as for ES, the batches are going on. You can join there, enroll there. Mega mock challenge test going on 14th August and 29th August. You can sit for the Gate 2022 and BARC 2021. Here is the first question to all of you. The beam AB will be subjected to a quick session. A beam AB will be subjected to. What will be the answer for this one? Can you tell me? Beam AB will be subjected to. Is it visible to you all of? Is it visible to all of you? Okay. Oh, that's great. That's great. So now, as the force is acting at this location, as the force is acting at this location, what will happen? Simply you shift it parallelly. You shift it. Now this is the line of action of the force, and this is the axis. This is the axis of this bar, and the another one is like this. So here if you parallelly shift it, what will happen? The load will be shifted. Along with that, stand here and see how you have shifted the load. What actually load was doing there? It was rotating about this joint. The length was L, so P into L, it is going to rotate. That rotation will provide the torsion or twist to the beam AB, right? Now it will be subjected to, the beam AB will be subjected to bending. If you take the section at any position, it will be subjected to bending due to the load into the distance here, right? And due to the load, it will be having shear force, and this P into L will create the torsion. So it will be having all the three. What about this one? For the given loading, the distance from left hinge support where the shear force will be zero. Where the shear force will be zero. for the given loading, the distance from left hinge support where the shear force will be 0. Understand one more thing, you will not be having that much of time, so you have to decide which question you need to attempt there and how. Actually you don't have much time there for the BARC examination, right? For a given loading, the distance from left hinge support where the shear force will be 0. So here two things you have to do, isn't it? Two things you need to do it. First of all, you need to shift the load here. You need to shift the load. So I will just construct once again I'll construct the diagram. This is your beam, and when you are shifting the load, while you are shifting the load, the parallelly you shift it over the beam, it will be quite easy for you to analyze, right? So parallelly, first of all, a load will be shifted and a moment is going to come, that is 10 into 3, that is nothing but 30 kilonewton meter, isn't it? And you have a UDL, over it, right? UDL over it. Now the axial force is not going to do anything here. What we'll do, just calculate the reaction over these two places. So if the length is 6 meter, how you will calculate the reaction quickly? Symmetric, right? Symmetric. So total load is 12, half of that will come here and half of that will come here, that is 6 and 6. That is all due to the UDL. Then a net moment is there, that is 30 kilonewton meter, which is acting clockwise. So an anti-clockwise moment will be generated. By the reaction, right? And the value will be, the magnitude will be the net moment divided by length of the beam, that is nothing but 5 and 5, isn't it? Net moment divided by length of the beam. So final reactions you can understand, here you have a 1 which is acting upward, here you have 11 which is also acting upward. Now if you draw the shear force diagram, you will understand here. If you draw the shear force diagram, here you have a negative 1, that is 6, right? And from here to here you have a UDL. See, now UDL, along with the UDL, one should understand that you have a moment and axial. They are not going to disturb your shear force diagram. Here you have a 1. So of course somewhere here only your shear force is going to be 0. Take the section here, write down the shear force. Simple. Write down the shear force. See the left side here. Shear force is how much? 1 is acting upward side, rotating about me in a clockwise direction, that is +1. Then what? UDL is, I will take a minus. So what is the total UDL? I have taken it at a distance x. So total load will be, that is 2 into x, isn't it? 2 into x, that must be equal to 0. So x will become simply 0.5 from left support. That's all. If you will practice it, you can do it quite easily. That practice has to be done. The previous year paper and all, they are not available the way you are thinking. It is not like any of the other examination where previous year papers are available. Here whatever the students are saying on basis of the students personal experience and whatever they can remember, based on that only you will get the questions which came in the examination, right? Now what will be here? For the given loading, the distance from the right hinge support, right hinge means at from B, where the shear force will be 0, from the right hinge where the shear force will be 0. Very quick, you can solve it. Quickly you can solve it. I want to see that how many of you can solve it very quickly. From B support, at which location your shear force value will be 0. That's great. Now if you see here, it is quite easy. If someone has given the directly reaction, do not ignore it. See, if the people have given the reaction, do not ignore it. And at the same time, if reaction is not given also, this type of simple beam, it is quite easy to calculate the reaction. Suppose if it is not given, suppose the reactions are not given, then what? First of all, okay, if the reactions are not given, how much time it will take? That you have to understand. Total load is 5 to the 10. So RA plus RB is nothing but 10 and you take the moment at A, so you'll get RB into 5 and equals to 10 into 4. 10 into 4 and RB simply will become how much? See, 8. So directly you can do that. It will not take more than 15 seconds to calculate. If RB is 8, RA you will get 2. That's all. See, RA you will get 2. So calculation of reaction also will not take time, isn't it? So 8 and 2. Now if it is given, now it is a piece of cake. Why? Because you draw the shear force diagram. You draw the shear force diagram. It is quite obvious. You don't have to draw also. You'll come to know very easily how to do that. See, check this. See here, what is the shear force at this location? Here you will be having -8. Achha, after that you check the location, which section you have to take here. Only you need to check the location. You check what is the shear force at this location. Shear force at this location, that is at XX, you should write down. Shear force at this location will be how much? Simply minus of 8 and plus 5 to the 10. That's all. It is plus 2. So if it is plus 2 here and minus 8 here, it is very obvious that it is going to come at this location, isn't it? Oh sorry, this is a shear force diagram. So it is quite obvious that it is going to come at this location only, right? Now take the section in between. Take the section here only. Take the section here only in between that loading, right? And make it to 0. That's all. Make it to 0. So at this section, if you are taking the shear force at some x distance, what is that total shear force now at this section? Shear force, if you write down at that particular section, it will be once again minus of 8, then plus intensity. Loading intensity is 5 into x must be equal to 0. So x will become 1.6. That's all. That's all. See. Did you get that? Now, for the given shear force of a loading on a beam, what is the total downward loading? What is the total downward loading? Meanwhile, you please share it. Share it with your friends. Do the like, hit the like button also. Yes, that's great. See, you have a two approach here. If it is, see, it looks like it is a simply supported. How? If I'll say that here, if you'll stand here, this is minus of 22.5. If it is a beam, a concentrated load is acting from upward. That is why if you are standing at this location, that is why if you are standing at, this is your beam, if you're standing at this location, this is the only situation when you will get the 22.5. And here if also you are going to stand, suppose this is your standing position, 27.5 positive, when you will get the 27.5 positive. See, those who have studied with me, they know that whenever you are standing over the beam, a clockwise rotation for the shear force, I have told you, take it as positive, and an anti-clockwise rotation about your considered section, take it as a negative one. So when you will get the positive, you will get the positive, that is only 27.5. If these two are the reactions available here, which is acting upward side, that is obvious, very obvious, that add these two, that 50 Newton. That's all. Add these two and 50 Newton. You check it out with the other way also. Check it out with other way also. Right? What is the different way of thinking about? See, now think in other way. Because it's a revision, everything must be cleared, right? So here, if you see, from left side, if I am trying to move from left side, so it is already 27.5 is upward. If it is coming downward, there is some downward load. There is some downward load. Maybe it is in terms of UDL or maybe in terms of directly concentrated load. Observation of the shear force. This is your standing position. You are moving towards this side. It is already a 27.5 positive, that for the positive it is upward. Now whatever the shear, whenever shear force is coming down, it is only due to the downward load which will bring down the shear force. Right? Now move it and you see from this location to this location, what is the total downward force? What is the total downward? That is 27.5 to 7.5. What is that? Amount you add it. That is 20. 20 is downward. I'm not worried about what is the intensity of the load. It is due to the UDL. I know that. It is due to the UDL. But what is the total load? 20 Newton. Then from here to here, no, nothing is working. Then from this location to downward this location, you have a change of how much? From 7.5 to minus 2.5. That change is of about 10 Newton, and that change is why? Because if downward load is acting, then only your shear force will come down. Then what? Here to here you don't have any problem. Then afterwards, once again a downward loading is acting. That's why your shear force diagram is coming down. A concentrated load is acting. That is why it has a sudden change. So total, actually now I'm adding only the total downward load. I'm not worried about where the concentrated load are acting, where the UDL is acting. Although I have, this is due to UDL and this all too is due to the concentrated load. Here it is coming down from 2.5 to 22.5. So once again 20 downward, 10 down and 20 down. So that's all. That's a total 50. So either you add this way or that way. Both way are okay, right? Practice it. Practice it. Is it clear? Now what about this one? For the beam as shown in figure, the distance to the point of contraflexure from the fixed end A is. For the beam as shown in figure, the distance to the point of contraflexure from the fixed end A is. Can you do that? This is your propped cantilever beam with overhanging portion. Propped cantilever beam with the overhanging portion. It is your indeterminate one. But fortunately once again, the unknown is given here. If the unknown is given, it will become a piece of cake once again, isn't it? If the unknown is already given, it will be a piece of cake. What we'll do here? Can you do the calculation and check it out how much time you are taking out while solving it? Okay, that's great. Now he's asking about point of contraflexure, right? Now it means you have to draw the bending moment diagram. Draw the bending moment diagram. Draw the bending moment diagram. No need to calculate the reaction. Already things are given here, right? At a free end, if no moment is acting, of course it will be having a zero bending moment here. You stand here. I will change the color now. First of all, stand at this location and calculate what is the bending moment. That's 5 into 0.25. That is 1.25. That too it is producing a hogging, so it will be negative. It will be negative from here to here. That is 1.25. Here at this location, this length is how much? 1.25. 5 into 0.25, isn't it? Then stand directly at this location. What is the total bending moment when you are going to stand here? 5 into 1 is hogging. So that is minus of 5 into 1. Then 8 into 0.75 is a plus 8 into 0.75. कितना हो जाएगा? 8 बचे 4 में 4 8 से 56 4 60 6. So it will be plus 6 and minus 5 plus 1. So you have a plus 1 at this location. Now this is your bending moment diagram. Once you'll get the bending moment diagram, you got the idea about that. At this location, somewhere at this location, you have a bending moment is changing sign from minus to plus or plus to minus. Now this is your point of contraflexure. So either you take the section here or you solve it through the similar triangle, isn't it? Solve it through the similar triangle is also possible. X, you take it here and it will become how much? Simply 0.75 minus x, right? Then use the similar triangle because you know this height is 1. Or if you want to write down the equation, that also can be done. So write down the bending moment at this section. You stand here and write down the bending moment. Take the maybe distance from here, that is some x. At x distance, you write down what is the bending moment. So bending moment at xx section will be how much? 5 into this distance I have taken x, so 5 equals to 0. I'll do that. So 5 into x plus 0.25, that will be minus, right? And then what? Plus 8 into x will be equal to 0. From here, if you solve, you'll get something around maybe 4.4. How much you will be getting? 0.42 something, right? From here you'll get 0.42. He's asking from end A, just minus from 0.75 and you'll get this distance. That 0.75 minus 0.42 and you'll get 0.33. So either you do with the similar triangle or you do with this, you'll get the same. That's your choice now. If you are feeling comfortable with doing similar triangle, do that, or you do this one, whatever is easy for you. Simply supported beam AB has a bending moment diagram as shown in the figure. The beam is possible under the action of following loads. Which one is correct here? 10 seconds only. 10 to 15 seconds it needs to answer the question. Which one is correct here? See, in a bending moment diagram, if there is a change, sudden change, that is all due to C language. I like C language. See, nowadays maybe the book, there will be a lot of available book. I used to study that C. Balaguru Swami. You read that book, I don't think it will take more than a month. If you are logically sound, your aptitude skill is good, then I don't think it will take more than a month. So Balaguru Swami is good book. Read it out. Okay. Now here whenever you have a sudden change, that is about the due to the moment which is acting over the beam. So there is a moment which is acting over here, that is M. So total change, go for the total change. Here the total change is for M. Here the total change is from M to minus M, that is 2M. So yes, at C M is acting and at D 2M is acting. That's all. That's all. No problem. You study that C. Balaguru Swami. Now here a cantilever beam OP. Yeah, that is good. Kanitkar. Huh? Let us see, that's Kanitkar. Are you talking about that one? Now this is also very obvious type of question. Very obvious type of question. A cantilever beam is there. He is asking what is the magnitude of bending moment at fixed end O. How you will do that? Whenever you have an internal hinge and you have a loading like that. Oh, that is NCC. Okay. Whenever you have a loading over here, what will happen? Achha, how to understand this? Several times I told you for that, because there will be no bending moment at your position P. So do one thing. Whenever you have a loading, I'll draw that one. You understand? See, this is not the correct way maybe, but it will help you a lot. This is one beam and it is internal, so think that it is kind of actually it is not a roller, because now if you provide a roller, it says that axial force will also not generate here. So but you understand that one is kept over the other. See, that is just for your feeling. This is not the correct representation. Once again I am saying it, just for your feeling. You understand that whenever you have a load, it is just kept over it, or it will be better whenever the load is going to come over this beam, it will act as a support here. It will get the reaction from here. Then a 10 kilonewton, whatever. See, even though if it is given at mid, no, you'll get 5. That is quite obvious. If another ratio is also given, 10 into far end divided by total length, you do that way. So find it out the reaction the way you do it for any simply supported beam here, and whatever the reaction you are going to get at P, you just transfer the reaction over that another beam, transfer it to the another beam. That's all. Transfer it here to the another beam, because whatever the reaction he's getting it is all due to the beam OP. And simply the 5 into the distance 2, 5 to the 10, and 10 will be acting here. That's all. A simply supported beam has a shear force diagram as shown in figure. Which of the statement is correct for loading diagram? Which of the statement is correct here? Can you tell me which of them are correct here? Which option is correct here? Okay, that's great. So check it out. See, a simply supported beam. See, already he is specifying, no, it is a simply supported beam. That's great. Simply supported beam, already it has been specified. Now see here, I'll draw it once again. We'll talk. It is a simply supported beam, and this is your shear force diagram. Now the way I told you, if you are standing at this location, this is your standing position or considered section, should I say that, like as a considered section, when you will get the 23 kilonewton, because if you have a upward side, that reaction 23, then only you'll get, it will be rotating. If you're standing here, this is your standing position, it will rotate about you in anti-clockwise. That is why you're getting minus of 23 here. If you're standing here, you are getting what, 25. So bring that over your beam, make it as simple as that, no more confusion, huh? So if you're standing here, when you will get the 25 kilonewton here plus, so if a load is acting, that may be a reaction 25 kilonewton, because this is your standing position. The force is now rotating about you in a clockwise, so 25 is now positive. That is how you are getting positive here and negative here. Then if you are coming down towards this side, it is going down. What is the case? Down means you have a downward load which is bringing it down from here to here. Now I will be asking, what is the intensity of the load? So total load by which it is coming down from 25 to 10. So total change is how much? Total change is 15. 15 over the 3 meter. The change of the load 15 over the 3 meter. So 15 divided by 3 will give you the intensity of the load. That is slope of that inclined line. Did you get that? 15 is the height and 3 is the length. 15 by 3, that is 5 is the intensity here. 5 Newton per meter, isn't it? 5 Newton per meter. Then what? From 10 to 2, you have a concentrated load which is bringing it down. So shear force always has a sudden change when you have a concentrated load over it. So you have a concentrated load of 8 kilonewton. Why? I think this is kilonewton, right? Kilonewton. So it is not Newton, it is 5 kilonewton. Sorry for the unit. This is 5 kilonewton per meter. Then this is 8 kilonewton, right? Then after 2, if you are coming down, you'll see that from 2 to from this location to this B point, actually it is continuously coming down, continuously. So you once again you have a continuous UDL which is downward side. But what is the intensity? So as I told you, it is about the slope, and this distance is given, the 5 meters given. I don't worry about anything. I just will find, I'll be more interested to find out the slope only, right? That will give me the intensity of the load. So total distance is 5 and total downward, see by what amount it is coming down. It is not 23. Do not misunderstood that one. It is not 23. It is actually, this height is actually how much? 23, and here already 2, that is 25. 25 is the height. So this is 25 and this is 5. So 25 by 5, once again it is 5 kilonewton per meter. You check it out always, because the slope may be sometimes different, or different intensity of UDL will be working or will be loaded there. So you need to check it out. Now this is a complete loading diagram. Now he's saying that 8 kilonewton is acting downward on the beam. That's correct. UDL of 5 kilonewton meter is acting on the beam. That's also correct throughout the beam. Then what? Reaction at the support A is 25 kilonewton. That is also correct. Done. Do you know one last thing? I have never said that one, maybe. It is not asked here. Now take it as a gift. Now, while drawing the shear force diagram, by seeing the shear force diagram, one cannot identify the application of the moment. So check it out for the moment equilibrium here. What will be the moment equilibrium? So consider the location. Find it out. The summation of moment at any position must be equal to 0. Calculate it. Maybe you consider the moment at A. You calculate what is the moment it is going to come over A. What is that moment? So 23 into, it is rotating anti-clockwise, take minus, no problem. 23 into how much? The distance is 8. Then 5, that is plus 5 into the total length is 8, and it is acting at 4. Then you have a concentrated load 8, which is once again rotating clockwise. So plus 8 into the distance is 3. How much is the value? Can you tell me what is the value here? -184 प्लस 8/40 4 को 16 160 and plus 8 3 24. How much you're getting it? You're getting 0. That's correct. Means no moment, no extra moment is required to apply it there. If you will get, suppose you are not getting 0, suppose I'm getting some minus of 20. Suppose what does it mean? Minus means we have assumed that all anti-clockwise moments are, so minus means I'm getting some minus moment is going to be there. So what you have to do, apply clockwise moment. Then you'll be asking, sir, where to apply? Array, apply anywhere. No, you cannot identify where to apply. Anywhere on the beam you apply plus 20, that's all. That is, clockwise moment must be applied to maintain the moment equilibrium. That is the last thing one should check. It is not needed here at all. Do not do not confuse yourself. It is just an extra thing I told you. Not at all needed here. Not at all needed. For the completion purpose I told you. What about this one? A simply supported beam has a shear force diagram as shown in figure. Which of the statement is correct for the loading diagram here? Please consider the length as 10 meter. If the length is 10 meter, which of them is correct here? Length is 10 meter. Do that. See, once again he is saying that it is a simply supported beam. That's great. Length has been given. Now simply supported beam. Okay. Why I am giving the supports here? See, if it is simply supported, reaction will come. There is a sudden change at this location only, and there is a sudden change at this location only. So of course the supports will be here only, isn't it? Did you get that? Now, as I told you, if I'm standing nearby this, the amount value is 2 kilonewton negative. When I will get that? If it is acting upward side, then only it will be rotating about me in anti-clockwise, and I'll get minus of 2. That's great. Now if I'm standing here also, after standing here, I'm getting minus of 2. How I will get minus of 2? If I'll get the reaction which is downward side, it will be rotating about me in anti-clockwise, then only I'll get the minus 2. So the value is 2 here, and here the value is 2, and the direction for both the reactions are opposite to each other. What it shows? It is now generating a moment. It is generating a moment. They both of them are actually generating a moment. They are generating a moment in which direction? They are generating a moment in which direction? They are generating a moment in anti-clockwise direction. So there must be a clockwise moment acting over the beam, against which they are generating the moment. That's all. And what will be the value? If you have a moment of, suppose, any m, how I told you, net moment divided by length of the beam. So m by length of the beam is 10 equals to 2. So you know that m is 20. So that 20 kilonewton meter is acting here. 20 kilonewton meter, that too in a clockwise direction, very specifically, because reactions are generating a moment anti-clockwise. So a clockwise moment will be acting over the beam. You may ask, sir, where it is acting? No one can tell. You may apply the 20 kilonewton meter clockwise anywhere over the beam. From the shear force diagram, one cannot identify the location of the moment. Did you get that? That's all. What about this one? A simply supported beam has a bending moment diagram as shown in figure. Which of the statement is correct for the loading diagram? Please do that. That's great. Once again, he's saying that it is a simply supported beam. simply supported beam. See, practice the way I am telling you. It will be very much helpful. It will be very much helpful. Now, this is your bending moment diagram, and it is a simply supported beam. If you have a bending moment 0 at this location and at this location, that is quite obvious. Now if it is simply supported, obviously you have a support at these two locations. That is why you have a bending moment 0 at these 2 points. Now, oh, I'm sorry, this length once again 10 meter. I'm really sorry for that. Length also once again 10 meter. So when you'll get 6 kilonewton meter, if it is 10 kilo, see, total change of moment, if you see here at this point, there is a sudden change, and the sudden change is about 20 kilonewton meter. That is 100% sure at this location over the beam at 20 kilonewton meter. Now I don't know about the clockwise and anti-clockwise, just simply I have considered that at 20 kilonewton meter is acting here. Now 20 divided by length of the beam, if it is 10, you will get 2 and 2. If it is clockwise, they will generate anti-clockwise. That 2 and 2, isn't it? If it is clockwise, the anti-clockwise moment will be generated by the reaction. That is net moment divided by length of the beam, 2 and 2 kilonewton, with the opposite sign, opposite nature. Now you calculate whatever he is asking. 20 kilonewton meter is acting on the beam. That's correct. Moment is acting at 7 meter from the support A. That is also correct. From seeing the diagram only, without this much of deduction, one can easily say that yes, from A support there is a sudden change of moment from 6 to minus 14. That is total 20 kilonewton meter change is there. So that 7 meter, yes. Now okay, this 7 meter you have to ensure, isn't it? 7 meter only you have to ensure the distance. Now the 10 meter should be given. Without that it will be difficult. So when you will get that, so here if the distance, you don't know distance, here it is 14, right? When you will get the 14, 2 into 7 only you will make 14. If you are considering the section just before the moment, when you will get the 14, it must be 7, then only you will get 14. So it is correct. Reaction is 2 kilonewton, that is also correct. So all are correct here. Yeah, length I missed it. Now what about this one? For the beam as shown in figure, the design bending moment will be. Which bending moment you will be considering for the design purpose. That is quite obvious. The maximum one only you will consider for the designing purpose, isn't it? Now if you see what is the reaction here, you just calculate it. The reaction can be calculated very easily. Draw the bending moment diagram. So calculate the reaction. This is symmetrical, so 2 to the 4. So 2 and 2 will come first of all. 2 and 2 will come due to the reaction, due to the UDL. And a net moment is 20, which is acting clockwise. So net moment divided by length of the beam, that is 2 plus 1 plus 1, 4. 20 by 4, 5. And 5 is actually reaction they will be generating anti-clockwise. So that is due to the moment. These reactions are due to the moment. That is 5 here and 5 here. Look at that. And it was kitna 2 4, so 2 here and 2 here. What is the final reaction? 3 downward side, 7 upward side. 7 and 3. So you have 3 downward side here and you have a 7 upward side here. Now if you draw the bending moment diagram, for this one. Here it directly moment is acting, that is 20, you keep it here. Then you stand here and see what the moment is doing. It is hogging, so negative minus 20, negative of 20. Then from here you just come to this location. What is the bending moment at this location? It will be somewhere, maybe it will come down, isn't it? So that 20 was minus and then plus 7 into 1, so it will become 13. So here it is 13. Then from here to here, just to come at this location. Acha, here if you are standing, what is the bending moment? It is 0. At end hinge support, it will be 0 only. Now you see, if the bending moment is now coming down like that, is there any possibility to get more than any 20 kilonewton? No, not at all. It is 13 already. And if you are going to calculate at this position also, so 3 into 1. you are going to get 3 into 1, that also once again minus. So it is a complete minus. It is a complete minus. Between here to here it is a line, here to here it is a straight line, and in between you have a curvature. But nowhere it is you have more than 20 kilonewton meter. Nowhere over the beam you have a 20 kilonewton meter moment. So the designing will be always the maximum magnitude must be considered. That's all. Maximum magnitude must be considered. Did you get that? Now what about this one? The bending moment at A for the beam as shown in figure. What will be the bending moment at A for the beam as shown in figure? That's correct. That's correct. See, you can do it in a two different way. Understand it. One thing is that directly you see, directly you stand here and see what is the bending moment he's asking at A. While standing here, you'll see that 20 kilonewton is directly acting over here. That is producing a sagging moment. So take it that plus 20, and the 10 line of action of the force. If you see, the 10 into 2 is actually producing a hogging one. So minus of 10 into 2, and you'll get 0. You'll get 0. But suppose if you want to shift the load also, you can do that by shifting the load. By shifting the load also it can be done. If you want to do this, it will not take that much of time. Did you get this one in a one line? Now you want to shift the load, shift it. 20 kilonewton directly can be shifted here. Now shift the load first of all. Shifting the load here, it will come down here, that 10 kilonewton, and the distance is 2. So anti-clockwise moment will be generated. That value will be 20. Now if you draw the beam, what are the loads or moment acting over that joint, over that free end, or maybe this end B. See, directly moment which was already acting, which was a 20 kilonewton meter acting in a, oh, that was acting like this. This is also acting like the, oh, both are acting in the same direction. 20, it was acting earlier, and now due to the shifting of the load, at 20 again is coming down. At 20 again is coming down in the same direction. So 20 plus 20, I can say that a 40, directly 40 kilonewton meter is acting here. Now you have shifted the load, that is 10, and that 10 will come down like this, isn't it? Now you check out the bending moment. So what is the bending moment? Both that 40 kilonewton meter will produce a sagging to your beam, that is plus 40, and 10 will produce hogging, that 10 into 4, that minus of 10 into 4. That's all. Either you do this way or that way. Wherever you feel comfortable, you can do that. It is once again 0. That's all from my side. So tomorrow, do not miss it. Tomorrow we have very important session of strength of material. Do not miss it. Once again, we'll be doing the fantastic questions on the strength of material. Practicing strength of material questions is always good, isn't it? Good and energetic too. So once again, congratulations to all of us for a gold medal, isn't it? So these are the star faculty of the Gradeup, star students of the Gradeup who got rank, and there is a Gradeup Super subscription for all the structured live courses, and green card which ensures you all the live online mock test you can sit for. So you get one subscription and it will give you all the opportunity, all the structured live courses along with the green card. And tomorrow once again at 3 p.m. we will be meeting with the fantastic questions on strength of material. Thank you everyone. Thank you everyone. Good night. So we'll be meeting tomorrow once again at 3 p.m.